in this is not new chapter because it was there in 9th class, where you identified polynomial from the given algebraic expression under some condition, an algebraic expression will become a polynomial. And then you got the zeros of linear polynomial. In 10th class, you have to find the zeros of quadratic polynomial. So what you have to do, you have to factorize quadratic polynomial, then each factor of quadratic polynomial will be a linear polynomial, and then equate each of them with 0, you will get the zeros of quadratic polynomial. That is the second thing here I wrote. But you have to find the polynomial, you have to find a polynomial when the zeros are given. And the second thing, you have to find the zeros when polynomial is given or the graph of polynomial is given. If graph of a polynomial is given and it is written y equal to px, then see the point of intersection of the graph on with x-axis. And if x equal to py, then see the point of intersection of the graph on y-axis. So these things we have to do here in MCQs. So bachcho, I'm moving to question 1. Here question 1 is on the screen. If alpha and beta are the zeros of a quadratic polynomial, this is a quadratic polynomial, so you have to find the value of k. Actually they gave alpha minus beta, it means find alpha plus beta. So as you know that alpha plus beta equal to minus b by a, so a is coefficient of x square, that is 1, b is coefficient of x, that is minus 5, and c is the constant term. So alpha plus beta, this is equal to minus b by a, and this is equal to minus 5 by a means 1, and this is equal to 5. So alpha plus beta equal to 5, alpha minus beta equal to 1. If you solve these two equations already by using pair of linear equation, already you did it. So beta cancel, I am using elimination method, it is 6, and then alpha equal to 3. So if you substitute the value of alpha here, alpha plus beta is 5, so beta will be 2. Now c equal to k, so alpha into beta, the next relation, this is c by a. So alpha into beta, 3 into 2, c means k and a means 1, so 6 equal to k, so c bit is the correct answer. Now moving to second question. If one of the zeros of a quadratic polynomial, this is minus 3, so just you substitute this value in the given polynomial. 0 means value of the variable, that is x, minus 3 square plus k minus 3 plus 1, it will make polynomial equal to 0. So 3 square is 9, so 9k minus 9 minus 3k plus 8 equal to 0. So 9 minus 3, that is 6k, and minus 9 plus 1 minus 8 equal to 0. So now 6k equal to 8. So k equal to 8 by 6. 2 4s are, 2 3s are, so k is 4 by 3, means first bit is the correct answer. Now next question here, see, we have to find a quadratic polynomial whose zeros are minus 3 and 4. Because two zeros are given, so polynomial will be quadratic. 1 0 is given, polynomial will be linear. 3 zeros will be given, polynomial will be cubic. And this is the basic concept to find a polynomial when the zeros are given, that is x minus alpha into x minus beta. If one more 0 is there, then into x minus that 0. One more 0 is there, x minus that 0, then multiply all brackets, you will get polynomial. So k x minus minus 3, x minus 4, so k x minus minus plus 3, x minus 4, and then k using formula x plus a into x plus b, that is x square bracket a plus b, that is 3 minus 4 is minus x plus ab. So 3 into minus 4 is minus 12. There is no denominator, so k will be 1. So the required polynomial will be x square minus x minus 12. So this is the answer and this is bit 1. Now next question bachcho. Here if the zeros of a quadratic polynomial, it is x square, a plus 1 into x plus b is 2 and minus 3. You have to find the values of a and b. Both zeros are given, so find with the help of relation between the zeros and its coefficient we can get these values a and b. So we know the relation alpha plus beta is minus b by a and alpha into beta c by a. Alpha is the first zero, beta is the second zero, minus b is the coefficient of x, a plus 1 by a is coefficient of x square, that is 1. So minus 1 equal to minus a minus 1. So take a in this side, so a equal to minus 1 plus 1, this is equal to 0. So a is 0. A is 0 means d bit is correct, so no need to find b, because in the remaining bits a is not equal to 0. So we got a equal to 0, so no need to find b, because b must be minus 6. Now the next one, the number of polynomials having zeros as minus 2 and 5. So there are infinitely many polynomials if one zero is given or two zeros are given, so more than 3 will be the answer. Now the next question. The zeros of a quadratic polynomial, this x square minus 15x plus 50 are both positive, both negative, one positive, one negative. See, here the product of a and c is positive. A and c is positive, c plus 50. If you multiply these two, that is equal to plus 50. And the middle term is negative. So middle term is negative. So it means you have to find two numbers, both numbers should be negative, into negative equal to positive. So if it is negative, it means you will get a factor x minus a into x minus b. And when you equate each factor with 0, then both values will be positive. It is one way. Second way, if you don't understand this, so what you do, you just factorize. So x square minus 10 5s are 50 into x plus 50. So x minus 10, see both numbers are negative, minus 5x plus 50. X is common, so x minus 10, minus 5 is common, so x minus 10, and it is x minus 10 where I told x minus a, and the second factor is x minus b. Here the both values of x will be positive if you equate with 0. That's why I wrote that answer plus. If 1 0 is this, 1 0 of a quadratic polynomial is 2, then the value of b. So what you do, 0 means the value of x, so you write x equal to 2 in the given polynomial. Polynomial is px equal to x square plus 3x plus b. So p2, so it is 2 square plus 3 into 2 plus b, so it is 0. Actually we are using remainder theorem, it was in 9th class. Plus 6 plus b, 6 plus 4 is 10, so minus 10 equal to b. So d bit is the correct answer. Now next question, if one of the zeros of a polynomial, if one is the one of the zeros of a polynomial, then find the same thing. You just write x equal to 1 in the given polynomial. This question and previous question both are same. So x square plus x plus k. So p1, it is 1 square plus 1 plus k. It is 0. So 1 plus 1 plus k. So minus 2 equal to k. So this is the answer. Now here the graph is not given, so leave this question. Graph is given in booklet, and that is a quadratic polynomial. It is given in booklet. Now if the product of the zeros of quadratic polynomial, this is 4, ax square minus 6x minus 6. Product is 4, means alpha into beta is 4. So alpha into beta is 4. Alpha into beta means c by a equal to 4. C is minus 6 and a is a equal to 4. It means 4a equal to 6 minus 6. So a equal to minus 6 by 4. 2 2s are 2 3s are minus 3 by 2 means first bit is the correct answer. Really is very interesting, very easy chapter. See x square plus 2. This is a polynomial x square plus 2. Question is we have to find the zeros. If you write x as 1, so x square plus 2 it is 3. If you write x as minus 1, so it is x square minus 1 square plus 2. This is also 3. It means for any value of x, this never be equal to 0. If you write p0, still it is not equal to 0. It is equal to 2. Minimum value is 2. So there is no any value for x for which the value of this polynomial will be 0. It means this polynomial has no 0. So here answer is none of these. Otherwise they can give one option. It has no 0. Now the next one. This one, the zeros of a polynomial y equal to px. See, it is px. It means you have to see the point of intersection with x-axis. Y equal to px is the point of intersection of a graph of y equal to px and x-axis because it is x. The second question, it is x equal to py. Here is y. Here is y, so we will see the intersection of the graph of this polynomial with y-axis. Now, the next one, the zeros of a constant polynomial. Constant polynomial means any real number, suppose 5. If it is 5, you can't make it 0. It is a constant polynomial, it may be minus 10. For any value of x, it never be equal to 0. So, the zero of a constant polynomial 1, no. Any real number, no. It has no 0.